Enterprise Dynamics library contains a complete set of simulation objects which allow you to create different types of models. In this Get Started tutorial, we will explain several of these objects, such as the container, assembler, unpack, and conveyor atoms. The container atom is used for storing or stacking other atoms, typically product atoms. The container can resemble a box to store products, a basket in which parts are transported, or a pallet. A container atom, like the product atom, is placed in the model using a source atom. You need to connect the central channel of the container to the input channel of the source. An assembler atom can be used to pack products into the container. In general, the assembler can model assembly operations, packing operations, order pulling schemes, mixing operations, and many other joining operations. Make sure the container, main assembly component or order, enters the assembler via the first input channel. The atoms entering input channels 2 and higher represent the contents of a package or the subcomponents of an assembly. After an atom has entered through its first input channel, the assembler references its bill of material table to define the quantities of atoms to be joined from each other of its input channels. The bill of material table needs one row for each input channel. After all atoms have entered the assembler, which are necessary for the join operation, the cycle time starts. If pack content is checked, atoms that enter through channel 2 and higher are moved inside the atom that entered input channel 1 of the assembler. An unpack atom can later be used to get them out again. If pack content is not checked, only the products entering through channel 1 leave the assembler. The other atoms are destroyed. To transport the packed products, we add an accumulating conveyor atom. Although the conveyor is blocked, all entering atoms are conveyed until they reach another atom. Note that the products are now all stacked on each other on the conveyor. Products that are stored in the container can be animated in a pile or arranged in a grid. You need to adjust the container size and storage size. If you check Fit to Storage, you do not have to change the product size. In 3D, the products are animated as a cardboard box. You can also choose a cube which uses the color property. The products are now arranged in a grid. If you use an unpack, the container atom is sent out through output channel 2 and the content is sent out through output channel 1. You can specify the number of atoms to be unpacked from the container atom and set the cycle time for unloading the container. We now use a non-accumulating conveyor to transport the container. Note that the system blocks when the first container reaches the end and cannot be moved out. Containers cannot be conveyed anymore. This is because the conveyor is non-accumulating. When an atom enters the conveyor, it's conveyed by its length and possibly an additional gap. You can change the speed of the conveyor and the product spacing. You can also rotate the conveyor to make sure the flow of atoms over the conveyor matches reality. Besides the speed, the length of the conveyor also affects the time the products are on the conveyor. To have the product move from right to left, you need to rotate the conveyor 180 degrees. A multi-service has similar functionality as a server atom, but it can process several products simultaneously. The capacity determines the maximum number of products that can be served at the same time. You can influence the way in which the products are displayed in the multi-service. Because each entering product receives its own process time given by the distribution set in the cycle time, products that enter at a later time can leave earlier. This video showed basic functionality and use of the container, assembler, unpack, basic conveyors and multi-service atoms. Want to learn more? Watch our other tutorial videos. Thank you for taking the time to watch this video.